federated learning is another privacy enhancing technology that does not necessarily rely on cryptographic techniques. But the main idea of federated learning is that you bring the analysis to the data and not the data to the analysis. So instead of collecting all data that is distributed over many places in one central location and then training some sort of model, performing machine learning or other kinds of techniques, that's basically the traditional approach. What we now do is we keep the data separated and distributed, and we train the model locally and on one of these data sets, and then we continue with the model to the second data set, and we update the model based on this new data. So that's another way of preventing sensitive data from being shared or between different parties. That's different from the cryptographic techniques, multi-party computation and homomorphic encryption that we talked about earlier. And for some applications, federated learning can be much more efficient because it does not involve any complicated cryptography, which can sometimes be quite costly. The downside of federated learning, however, is that it does reveal or some information is shared between the different parties or the different data sets. So the data itself stays local and is not distributed amongst the parties, but the model that is trained based on this data is shared between the different parties. So the model parameters go from one party to the other, and the second party can learn something about the underlying data of the first party based on these model parameters. So that's sort of a trade-off between the different techniques. And what we also see that some experiments where instead of sharing the model parameters directly with the other parties in the plane so that they can see these model parameters, we can also share the model parameters using MPC or using homomorphic encryption. So then we share the model is trained locally, it is being encrypted, for example, with a homomorphic encryption scheme, then it is moved to the second party, and the second party can update these model parameters without having to see the model parameters. So then we see already a combination of federated learning and multi-party computation that seems to be a very strong combination.